Hello, this is Professor Urbis White. Now I'm going to summarize how you can solve any kind of trigonometric equation at any level. So I will just throw a couple of examples at you, but make sure that you do watch the videos, level 1, level 2, and multiple angle equations before you do this one. Otherwise, this is not going to make any sense. Alright, so let's get started. Let's say I have an equation, so you're going to put it all together. You're going to have to remember your identities and your angles and all sorts of stuff. So let's say we are asked to solve something like this. 3 cosine x minus 2 sine square x equals 0, and you want your x to be between 0 and 2 pi, so you want things in radian. Now for this one, the first step is to make everything uniform. So if you have cosines and sines, try to make them all cosine or all sine. So you have to kind of remember that. So I have a cosine and sine square. I know sine square and cosine square are related, so I will start with the identity sine square plus cosine square equals 1. So that means sine square is going to be 1 minus cosine square. I somewhat know where I'm going with this, because that way I will have a 3 cosine x minus 2. Instead of sine, I'm going to put 1 minus cosine square. Oh, guess what? I just got a quadratic formula. So FOIL this out. 3 cosine x minus 2 plus 2 cosine square x equals 0. Let's rearrange. 2 cosine square x plus 3 cosine x minus 2 equals 0. And guess what? This is factorable, because it's going to be 2, let's say smiley face square plus 3 smiley face minus 2, and that's going to be, when you remember your algebra, it's going to be this factorization. I use the trial and error method. So this is going to give me 2 smiley face square, and this is going to be -1 plus 4, so that's 3, and then -1 times 2 is -2. Okay, I got it. Now I'm going to get rid of the smiley faces and put cosines back in there. 2 cosine x minus 1 cosine x plus 2 equals 0. Okay, let's clean this up. Now with the property of factors, I have from here 2 cosine x equals 1, cosine x equals 1/2. From here I have cosine x plus 2 equals 0, cosine x equals -2. Here's a problem. This one's not going to work, so I cannot have a cosine that's less, that's -2 out. Now, what angle gives me cosine of 1/2? I go to my long-term memory. I know that one is pi over 3. Okay, now where is pi over 3? It's right here. Is that the only one? No. Cosine is actually positive right here. In a 1 revolution, I need to have this reference angle pi over 3 as well. But what is that from counterclockwise from the horizontal? So I have pi over 3, and this whole thing, 2 pi minus pi over 3. So what does that give me? 6 minus 1, 5 pi over 3. Alright? And am I in 1 revolution? Oh, I forgot to put that. No, I didn't. I need to stay in 1 revolution, and that's all I need. It's not a multiple angle problem. So your answer is going to be pi over 3 and 5 pi over 3. So strategy-wise, what did I do? Especially if you have cosine square, sine square, use the identity cosine square plus sine square equals 1. And then try to use factoring. It works most of the time. Alright, let's have another one. Well, if I don't have squares, what happens? Well, let's say I have a sine t, question is solved, equals cosine t plus 1. That one's like, oh, where am I going to go with this thing? I don't remember any kind of identity. Well, remember, squares kind of get you off trouble, so how about we square them? So when you don't have squares, just square them. So what do you have? And it's binomial squares, so make sure that you don't write something funky like cosine square plus 1. So you are going to open this up, so it's going to give you a trinomial, cosine square t plus 2 cosine t plus 1. Oh, now I'm getting someplace. Let's look at this. And I have sine square and cosine square, and I have a cosine. So it is better to go all to cosine, and I know how cosine and sine squares are related. Sine square is 1 minus cosine square, and then you have cosine square t plus 2 cosine t plus 1. Now let's move everything to the right. Then I'm going to move this to the right and move this to the right. So I'm going to have 2 cosine square t. Alright, when you move to this to the right, and now you're going to have 1 plus 1. So that's it. That's going to disappear. Oh, guess what? Second degree, but it's easily factorable. You take the 2 cosine t out. Cosine t plus 1. Alright, now what do? I set each factor to 0. That means I'm going to have cosine t of 0, or cosine t plus 1 is 0. What does this give me? Cosine t of 0, that is pi over 2. Is that the only one? Okay, here's one. Alright, that's pi over 2. What else is going to give me 0? This will also give me 0, right? So that will also be 3 pi over 2. How about this one? Cosine t is negative 1. Where is my cosine negative? Right here. So that is t equals pi. Is there another one? There is not another one in one revolution, because I want this to be, well, I forgot to put that. Keep on forgetting it. I want this to be that. But that depends on the question. If they want 4 pi, then you have to go around one more time. So this was in the question. So let's summarize. What do you have? You have pi over 2 from here. You have 3 pi over 2 from here. And you have pi from here, and you're within one revolution. Okay, let's look at another problem. Let's say I have a multiple angle problem. Solve. How are these? Just make sure that you do some practice with the multiple angle video. But let's say I have some like this. Cosine 4x. So these are multiple angle ones. Plus sine 4x sine x. That's the co-psi formula. That's the cosine. Remember how this is? This is A, this is B, this is A, this is B. If you remember your basic trig, what do you get? This is going to be, this formula is actually cosine of A minus B. Remember, cosine was. When you have negative, it reverses. So negative will give you positive, positive will give you negative. So this is actually this. And question was saying, let's write this down, 0 to 360 degrees. Alright, so I have cosine of a minus b, cosine of 4x minus x. That's supposed to be 0. And how does that work? So that means cosine, this problem became solve cosine of 3x equals 0. Now let's go to the original question. I multiply everything by 3. That means 3x is supposed to be 0 to 1080. So remember that. Now let's solve with that. You know, what cosine gives me 0? I know that the first cosine that will give me 0, so this is positive here, is this one. Okay? So I know my 3x is pi over 2. That's the first one. Let's do it in degrees, because this is given in degrees. So the first one is 90 degrees. What is the next one? This will also give me 0. How much is that? 1, 2, 3. So that's 3 times 90. That is 270. Alright? Do I have another one? Okay, 1080. So I think I have a long way to go. So let's add a 360 here. So that will give me 360, 460, 450. Is that under 1080? Yeah. Let's add another 360. What's that give me? 7 plus 6, 13, 630. Is that a good one? Alright, that's a good one. Alright, is that the only one? I have a long way to go. So I'm going to list these guys. So I have 3x, I got 90. I have 270. I have 450. I have 630. Okay, I keep going. So let's add another one, another 360. How much is that? That's going to give me 6 plus 5, 11, 4 plus 3, 7, 8, 810. Alright, that's still 1080, 810. Okay, well let's add that on. Okay, we're going, let's try that one. Does that also work? 360. So that's going to be 6 plus 3, 9. 6 plus 3, 9. 990. Whoa, that's still under 1080. Very good. Let's add another 360 here. Does this work? That's going to go over. It will throw it off. So that's where I stop. So my 3x is 90, 270, 450, 630, 810, and 990. Well, the problem is these are 3x. For x, I need to divide them by 3. So that's going to give you 30, 90, 150, 210, 270, and this one, 330. That is my answer. Alright. Now, another type of problem in solving equations may be systems. Alright, well, let's do a system problem. I'll give you something. It says solve the system y equals sine x, y equals cosine 2x. Alright? And then I want this to be 0 to 360. And this is in degrees. Now, what do I do with this? I have a sine x and cosine 2x. Now, but the thing is, if you remember your simultaneous equations, they are both y. That means sine and cosine 2x are going to equal each other because they're both y. So you have sine x equals cosine 2x. Okay? Now, my double angle formulas. What was that about? You just have to go to your memory. Sine x, that's going to be 1 minus 2 cosine square x. I'm not going to drive this. Go to identities and practice how to derive those double angle formulas. All right. Now sorry, what did I write? This is not cosine square, that's sine square. All right. Now let's put everything on one side. So you have 2 sine square x plus sine x minus 1 is 0. Wow, now I started with simultaneous equations, used it on the identity, and I got a quadratic. Leading coefficient not 1, so I have to go to intermediate algebra and try to factor this thing, or beginning algebra. This one factors, trial and error, 2 sine x minus 1 times sine x plus 1. Okay, what does that mean? 2 sine x equals 1, sine x equals 1/2. Alright, and how about this one? Sine x equals -1. Alright, what is that one? What sign gives me -1? That's going to give me this one. 1, 2, 3. So that's I'm doing this in degrees. So it is going, this will give me 270 degrees. And 1/2, sine of 1/2 is 30 degrees. Is that the only one? Alright, sine is positive here. So that means this is also going to give me sine of 1/2. So this one is the reference angle. So that means I need to get this blue one, and the blue one is 180 minus 30, which is 150. So let's put it together. What's the answer? I have a 30 degree. I have from here the red one, 150 degree, or the blue one, this one. And what else do I have? And I have this one from the other part of the factor, 270. And there is no other answer because I want to stay within 360. So just to summarize, how does this work? Try to isolate strategy. Isolate your trig function and solve with inverses. Okay, if you have multiple angle, solve for, let's say, nx, and then go to x and make sure you stay within the interval. If you have squares, try to use sine square plus cosine square. And again, if you have multiple angles, if it is a little complex and you cannot isolate it, try to use these formulas: a plus b, a minus b cosine, a plus e, a minus b. And then if you have simultaneous equations, you just solve them the way you solve any kind of algebraic equation. And if it is y equals, you set them equal to, just like the previous one. If it isn't, use either addition or substitution method. And that will pretty much summarize it. So good luck.